Assalamu alaikum wa rahmatullahi wa barakatuh, dear brothers and sisters. Welcome back to our journey through the golden age of Islam. In our last episode, we explored the translation movement, how Muslim scholars preserved and expanded the wisdom of past civilizations. Today, we meet one of the greatest figures shaped by that intellectual environment, Muhammad ibn Musa al-Khwarizmi, known as the Father of Algebra. His works laid the foundation of modern mathematics. Even the word algorithm, which powers our digital world, comes from his name. Let us uncover his life, his works, and his lasting influence. Al-Khwarizmi was born around 780 CE in Khwarizm, a region near the Aral Sea in present-day Uzbekistan. His birthplace was a crossroads of Persian, Greek, and Indian cultural influences. As a young man, Al-Khwarizmi moved to Baghdad, the intellectual capital of the Abbasid Caliphate. There, under the patronage of Caliph al-Ma'mun, he joined the House of Wisdom, Bait al-Hikmah. This was not just a library, but an academy where scholars from different faiths and cultures worked together. They translated Greek, Persian, and Indian texts into Arabic, debated theories, and developed new ideas. It was in this vibrant environment that Al-Khwarizmi produced his groundbreaking works. Al-Khwarizmi's most famous contribution is his book Al-Kitab al-Mukhtasar fi Hisab al-jabr wal-Muqabala, the compendious book on calculation by completion and balancing. From this title comes the word al-jabr, algebra. This book was revolutionary because it moved mathematics away from geometry and simple arithmetic toward abstraction. Al-Khwarizmi introduced systematic methods for solving linear and quadratic equations. He explained operations step by step, completion, al-jabr, meaning to remove negative terms, and balancing, al-muqabala, meaning to bring terms to equality. For example, if a merchant wanted to divide inheritance among heirs or a surveyor wanted to measure land, algebra offered a general solution, a universal method, rather than ad hoc calculations. His algebra was not symbolic like today's x's and y's, but written in words. Yet the logical structure was there. This shift laid the foundation for all later mathematics. Unlike some earlier Greek mathematics, which was often abstract and philosophical, Al-Khwarizmi's work was highly practical. Merchants used algebra for contracts, inheritance laws, and dividing profits. Its methods allowed engineers to calculate areas and volumes with accuracy. Algebra was vital in planetary calculations, determining prayer times, and finding the Qibla direction. The science of inheritance, Ilm al-Fara'id, required precise division of shares, which his methods greatly simplified. Through these applications, mathematics became an everyday tool in Muslim society. Al-Khwarizmi also played a key role in spreading the Hindu-Arabic numeral system, which included the revolutionary concept of zero. In his book On the Calculation with Hindu Numerals, he explained how to use the digits 0 to 9 in a positional system. This replaced the cumbersome Roman numerals and allowed easier arithmetic. Imagine trying to multiply or divide with Roman numerals like 24 times 53 compared to using 24 times 53. The difference is enormous. This system, through Al-Khwarizmi's works, spread westward into Europe, where it gradually replaced Roman numerals. It is the very number system we use today. Another of Al-Khwarizmi's legacies is the idea of step-by-step problem solving. His methods were so systematic that when his works were translated into Latin, his name was rendered as algorithmus. From this we get the modern word algorithm. Every time we unlock a phone, search the internet, or run a program, we rely on algorithms. The very concept rooted in Al-Khwarizmi's approach to mathematics, Al-Khwarizmi's works had been translated into Latin in Spain and Italy. For centuries, his book on algebra was the standard mathematics textbook in European universities. Scholars such as Leonardo of Pisa, better known as Fibonacci, studied Al-Khwarizmi's methods. Fibonacci's Liber Abazi which introduced Arabic numerals to Europe in 1202, was directly influenced by Al-Khwarizmi. Without Al-Khwarizmi, the development of European mathematics, Renaissance science, and even modern computer science would have been delayed by centuries. His ideas continue to echo today in classrooms, in science, and in the technology that powers our world. Al-Khwarizmi was more than a mathematician. He embodied the Islamic spirit of seeking knowledge and making it useful for humanity. His works remind us that Islam encouraged the pursuit of science not as an end in itself, but as a service to society and a reflection of Allah's science in creation. His algebra solved problems of his time, but it also laid the foundation for a global civilization that continues to benefit from his genius. Brothers and sisters, Al-Khwarizmi's life teaches us that knowledge is a trust, a responsibility. He turned numbers into tools for justice, trade, science, and faith. Today, when we hear the words algebra or algorithm, we should remember the scholar who gave them to us. In the next episode, we will explore the spread of Hindu-Arabic numerals and the decimal system, innovations that forever changed the way the world calculates. Jazakumullahu khairan for watching. Don't forget to like, share, and subscribe so we can continue this journey together. Assalamu alaikum wa rahmatullahi wa barakatuh.